we are going to build a spam detection classifier where it is going to classify between spam and not spam. Okay, now for that, what we need first? Tell me, to build this, what we need? Data. In one word, it's data. Okay, we need data which are spam and which are not spam. Simple as that, right? Keep it simple. So basically, let's have 100 emails. Okay, and let's say you have 100 emails. Let me just draw a block box here for 100 emails. Okay, so something like this is your 100 emails with us. This is your 100 emails. Understand this, understand the data carefully. Okay, so you have this 100 email data set with you, and out of these 100 emails, these are 100 emails. Okay, out of these 100 emails, we have managed to flag 25 of them as spam and rest of them as not spam. So out of these 100 emails, these are 100 emails, 100 emails, they are not spam or ham, we don't know. But once we annotate the data set, that means once we see which are the spam and which are the not spam, then we were able to know that 25 of them, okay, 25 of them were spam. So let's say 25 of them were spam. Okay, so 25 of them were spam and rest 75 were not spam. Okay, so here it is 25 as spam emails out of these 100, and rest 75 are not spam. Okay, so that is how your data set looks like. So you have 100 emails with you, and out of them, 25 of them are spam and 75 of them are not spam. Now, if we analyze the features, one feature, tell me, what is the feature of a spam email? What is, how will you detect, like in a very practical form, that how will you, if you see an email, will you be able to know that whether it is a spam or not spam? Unusually related to money, exactly, like people can say win a lottery, or cheap money available, or go to Dubai in just 299 rupees, all those stuff. Okay, so these are spam emails, these are called as spam emails, like some examples of spam emails. So let's take an example. Let's say if an email is containing the word cheap, I'm going to consider it as a spam. Okay, so if the email is containing the word cheap, I'm going to consider that email as a spam. So let me do it in a red color. If the email is containing the word cheap, cheap is a red flag, then I'm going to consider it as spam. Or let's say cheap in headline. Let's say if an email is containing the word cheap in the headline, then I'm going to, subject, not headline, subject. If the email is containing the word cheap in the subject, I am going to consider it as spam. I'm going to consider it as spam. Understood? Understood this cheap thing, what the cheap thing is representing? Everyone, cheap means spam. Cheap in subject. Okay, cheap is subject, is going to be the spam, spam for us. Okay, now we look for the word cheap in, at in at least 100 emails. Okay, in a data set we look for the word cheap. In the whole 100 email data set we look for the word cheap. Okay, and out of 25 spam emails, out of 25 spam emails, my 20 of them are containing the word cheap, let's say. Okay, 25, 20 of them are containing the word cheap. Okay, and 5 of them are not, uh, don't have it. Okay, so 20 of them are containing the word cheap. In my spam section, remember, out of 25 spam emails, 20 of them are containing the word cheap, 5 of them are not containing the word cheap. Okay, in the same way, in my 75 non-spam emails, 5 of them are containing the word cheap. Okay, are containing the word cheap, and 70 of them are not containing it. Okay, 70 of them are not containing it. So that is how the data set is there. So you have two classes, spam and not spam, and out in spam, 20 of them are containing the word cheap, and 5 of them are not having it. 5 of them are containing the word cheap, and 70 of them are not having the word cheap here. Okay, so now you got 20 cheap spam emails and 5 cheap non-spam emails. That means cheap is there in the subject, in the non-spam email section also, and spam email section also. So we forget about the rest of the emails. That means the emails that are not having it. Forget about rest of the email. The email that are not having the word cheap, forget about them, and you are just having 20 spam emails with cheap in it. Okay, and 5 non-spam. Understand this carefully. 5 non-spam emails with the cheap in it. 5 non-spam. Now, I'm going to ask you a question. Tell me that if you got a new email, if you got a new email, you have to consider the whole scenario here. You have to consider the whole scenario. If you got a new email and that email is containing the word cheap, what is the probability of that email being spam? What is the probability of that email being spam? Now, did you understand the question first of all? Did you understand the question first of all? Everyone, yes or no? Answer is a different thing. Did you understand the question or not? Okay. And others, 4 people have answered the question. Others, Rajesh, Ayush is left. 80. Okay. So Pratik, would you like to explain how you're getting 80 here?
Yeah, okay, sure. So if the email, if we are looking at the emails that contain chip, so let us
Mm-hmm.
consider at as it as 100%, because
Mm-hmm.
if we are looking only at the emails which contains chip in it, so
Mm-hmm.
100% of the emails we would have, right? So
Mm-hmm.
20 emails as spam among those emails which contains chip in it, and 5 are not spam. So
Mm-hmm.
if we calculate the probability, so if 25 emails we have in total,
Mm-hmm.
so so
20
into
is
4,
80%.
yeah, 20, yeah, 20 is 80%.
Okay. He's correct. So let me explain you. We can see that out of 25 emails, out of 25 spam emails, I'm talking about spam emails, out of them 20 are containing the word cheap. Okay, so whenever someone asks you the question, it is always based on the data that you're having. Okay, maybe another data is going to have another probability, but here in this case, if a new email come and that email is containing the word cheap, what is the probability of it being spam? So here you will go to the spam section and you see that out of 25 spam emails, 20 of them in my data set is containing the word cheap. That means 80% of my data set is containing the word cheap. So here it becomes 80% as an answer. Here it becomes 80% as an answer. Okay, out of 25 spam emails, 20 of them are containing the word cheap. Let's say if I'll say that if a new email comes and if that email is containing the word cheap, what is the probability of that email being not spam? Tell me what is the answer. What is the probability of that email being not spam? So everyone is going to say 20%. There are two ways to look at it. If the spam is 80%, then definitely the rest is 20%. And if you go to the 75 section also, out of 75 emails, 5 of them are containing the word cheap. That means 20% of the total emails are containing the word cheap, and that is why 20% is going to be the answer for not spam. Okay, so that is how the probabilities are calculated. And whenever uh, someone asks you the question about someone asks you the question like these, that means that person is talking in the terms of your data that you're having. Now, data changes, maybe answer gets changes. Okay, so conclusion here is that if an email is containing the word cheap, the probability of that being spam is 80%. Now, tell me one thing, a very simple question I'm going to ask you, that if you got an email like this, what is the probability of this email being spam? Anyone? If you have this email and what is the probability of this being spam? 25, 25, and everyone would say 25% because it's a straightforward question. 25 of them are spam based on my data, and 75 of them are not spam. So definitely it is only 25%. Okay, now this example is probability, and this example is the conditional probability. Okay, this is an example of a probability, simple probability. That means you're just asking about probability, but here it is conditional probability. That means you have put a condition that the email is going to have, either it is going to have the cheap or not cheap, sorry, either the email is going to be spam or not spam, and the condition is that email is containing the word cheap here. That is the concept, little bit about conditional probability. Okay, so we are going to associate the features with the probability here, with the probability, whatever the probability you're going to get, you're going to associate the features based on that, and we will use it to flag the future messages that you're going to get like this. Okay, so that is how the machine learn about it. So here you came to know that if an email is containing the word cheap, 80% is the probability that that email is going to be spam. 80% is the probability if that email is going to be spam. In the same way, what you will do, you are going to build for other features also, like spelling mistake is there. Okay, spelling mistake is there. Okay, or title is missing. Okay, or it is saying that free, these kind of words are there. Okay, or 100% off is there, all this kind of stuff is there. That means that email is going to be, is high chance it is going to be spam, and you are going to find the probability out of it. Let's say 70%. Okay, well, let's say that title is missing 95%, free is, let's say, 80%. Okay, and 100% off is, let's say, what, 50%. So just like cheap, just like the example of cheap, you're going to do it for multiple features of the spam email, and that is how you are going to learn about how to predict for a new data set, for a new data point, whether that email is going to be spam or not spam. Okay, now the algorithm that I'm talking about is called as naive bias. Naive bias algorithm. The algorithm that I'm talking about is called as naive bias algorithm. Okay, naive bias. Why the word naive we are using? You'll understand in a section of naive bias. Naive means inexperience, or the person who takes a decision without knowledge. Okay, without knowledge of a particular thing. So, like, inexperience in a single term, you can say. So, why we are saying naive? We'll talk about that in the naive bias section. Okay, but here is the gist of how naive bias work. Here is the gist of how naive bias work. The things to remember: the conditional probability is there. Okay, that means the word is cheap, or it is going to have a spelling mistake, or it is going to have a title, or multiple conditions are going to met, or free is there 100%, and so on. Okay, and based on that, it is going to have its probability based on the condition, and looking at the data set is we're going to have the probability. Okay, so that is how the naive bias algorithm work, and this is an example of NLP. We're going to make a project on NLP also. Okay, so this is example of NLP, which is natural language processing. That means trying to understand the natural language, like the language that we are speaking. Okay, but not in the terms of audio, but in the terms of text. Okay, so that is how the whole scenario is working. So everyone, did you understand how naive bias work in a nutshell? Everyone, did you understand the whole scenario here? Everyone, any question, raise your hand. Any loophole, anything you want to add or something, you can raise your hand simply. Okay, so that is what the naive bias algorithm work. That is how the naive bias algorithm work.